Hi, everyone. I currently work as the Climate and Environment Data Manager with UNICEF. As Maria mentioned, my previous roles includes a variety of different UN agencies. But today I put two logos here because I really want to talk about the entire humanitarian cycle, how geospatial tech plays a big role. But we will have plenty of time towards the end. Please feel free to ask any questions you may have, and I would be very happy also to connect after the webinar. So if you can, I'm just assuming you all can hear me well.
I see that now your voice is becoming not so clear as before. I don't know if you changed something.
No, from my end, I didn't even move. Sorry about this. I will try to stay closer to the laptop and talk a bit louder.
Okay, thank you.
Yeah. Okay, so I'm assuming many of you are familiar with the United Nations systems. UN has several different agencies and it's formed with all member states. So one of the questions people usually ask me is, how does UN respond to major emergencies, irrespective of where it happens in the world? And my answer has always been, we move. We move in a massive way. So the World Food Programme alone has 140 aircrafts, 20 ships, over 6,500 trucks, 50 of these innovative ships, which can go in any terrain. And believe me or not, we don't even know how many donkeys and horses are used in areas where we couldn't access at all. This is an example from Nepal earthquake. Irrespective of where it is in the world, our aim is to get there. If there is anybody who is in need, the UN works very closely with the host government and strives very hard to get there. But for us, the first important thing is to know where people are, right? So we have to go from data to information to decisions, and first step is in getting this data. And WFP collects massive amount of data for the whole world. It collects from vulnerability assessments all the way to processing satellite data to understand where an emergency might have happened. But even if we do that, even with all the satellites, all the radios, and armed with the most best technology that humankind has, we still struggle to answer some of the basic questions that we have. So before and immediately after a disaster, the first question you want to know, how many people would need assistance and where are they? And in today's world, it's 2025, and we would think, oh, that we should know that, right? And the second question is, how can we reach them? By road, air, sea? Are there any physical security constraints? Do we have access to get there? But that's not the only thing. Will people be able to reach us? Because we could go to a distribution point with food, with the medicines, with water, all the people need. But people also have to come to get those.
We are missing your slides.
Oh, I'm so sorry. Is the internet or the system not working well?
Yeah, we don't see your slide.
Okay, let me try again, and let me share.
Probably it's a problem of the internet, because generally when slides are made, it's due to the internet.
Okay, let me try again.
So now we saw the slide, yes.
Okay, fantastic. Sorry about that. So as I was saying, there are these basic questions which are very hard for us to answer. And geospatial information plays a very crucial role in this. As I say, everything happens somewhere. I'm assuming you can still see my slide.
Again, we don't see your slide. Oh my God.
That is quite strange, though.
Yeah, it is.
Okay, let me maybe instead share it.
So when you are we see that one slide. When you are changing slides, it doesn't work.
So what if I change this way?
Now we see. Right?
Okay, let me just do it without the animations then.
Okay.
Yeah. Okay, so one of the main thing that I live by is this point. Everything happens somewhere, and we need to know where it is. And here you have 3 screenshots, and this first one is from Google Maps. A couple of years ago, I was in this remote village in Republic of Congo, where the villages were very prone to floods, and I was sent for flood preparedness. As you can see in the first one, this is Google Maps, and there is barely one road in there. And the second one is a screenshot from Bing Map when I was there. That one road wasn't even there. You only see the international boundary. And the third map is what we were able to do together with a wide range of partners, including the OpenStreetMap community, to start mapping out where people are. So even in 2025, sorry, the slide says 2024, we are still not able to locate where villages are. And if they are not on the map, are they even there then? How would humanitarian aid reach people when they don't show up in the map? So that's the first biggest thing World Food Program started doing in the last 10, 15 years, is to try and map every single settlement, every road, every street, every admin boundary, airports, ports, name it, any infrastructure, logistic element that could be mapped. We started mapping it. With an army of volunteers, obviously. This is not something one organization, no matter how big it can do. So that's the first basic thing that we started with. And the second thing that I always tell people is everyone on this planet is at risk for some hazard. Nobody is free from hazards in general, irrespective of where they live. Now, the risk might be different depending on where we live. In Italy or in many of the Western, more developed countries, your vulnerability is really high. So even if there is a hazard, the risk remains low. But if we have to look at a child living in Congo, then the risk of the child to these multiple hazards is quite high because the vulnerability is high. Now, the second question we started asking, now that we have our base layers, where can a hazard happen? Where do people live? And how vulnerable they are? And we need to answer this question for the whole world. For every child living in the whole world is my current role. But of course, in World Food Program, it's all people who are food insecure. So that's what we started doing. We started mapping every single hazard we could think of, which could affect children anywhere in the world, irrespective of where they live. So here is an example of heat waves, taking data all the way back from 1950s and trying to understand how heat waves have evolved over time. And in order for us to calculate risk, we need to know the probability of heat wave happening. So it's not enough just to look at the past, because with changing climate, the past is not the signal of the future any longer. So we need to adjust for the changing climate and try to understand how much more children would be exposed to various phenomena. And we compare it with their grandparents' generation. A child born today is going to face multiple folds, each one of this disaster, than their grandparents did back in 1960s. And every data point that we try to measure gives us this shocking results of how much the climate has changed over the world and how much these hazards have been intensifying. And it's very important for us to be able to understand different dimensions of hazard. So what do I mean by that? One is to understand intensity. So how bad this hazard itself is in terms of heat wave. How frequent it can happen. So if it happens once in, if it has a 0.1 probability of happening, if it happens once in 10 years, now we see more and more bigger hazards are happening more frequently. And the third thing we look at is how long do they last? So heat waves were considered to be heat wave if it lasts for 3 days. Now we are seeing in some places it's lasting for 9 days, 10 days, very extreme temperature that children are being exposed to. And you can imagine children's reaction to heat is very different than adults. They also play outside a lot. So we need to really understand and help host governments, member states or countries in the world, adapt their policy to this changing climate. So that's where this data becomes really crucial, because it provides this evidence. And whenever we think of heat, we think of countries like India, where I'm from, or Sudan or Chad. But what we are noticing now is more and more, even in northern and southern latitudes, heat waves are happening more often. That is leading to forest fires and multiple other hazards, even in Western countries. And we started this massive work to build a global children hazard database. So we bring in as much data as possible with 20 different partners around the world and start understanding the world in different frames. And now we were able to build it for droughts, as you can see, where droughts are recurring and happening more often, riverine and coastal floods, where we are noticing floods are not only becoming more frequent, but they are also intensifying a lot. And it's not just the children that we need to understand the exposure of. Now we also need to understand the health centers, the education facilities, their homes, everything that they depend on. If it is in a flood-prone area, how does it affect their overall well-being? And we also started to notice that because of some hazards, especially cyclones and floods, there are secondary impacts, like malaria, are happening in places where we never have noticed that before. So this is a map of potentially where malaria could happen, and we notice that it's moving more and more to places, highlands, new countries, because the weather has become suitable for the mosquitoes' transmissibility. And then what happens is this concept of recurring hazards. So first, the temperature goes up, then they are faced with a drought or a flood, and because of the flood, water stagnates, then they get hit with malaria, and the cycle continues that there is no time for the society to recover, and that is the most crucial part of any disaster cycle. They need enough time to be able to recover and become more resilient, and there are some places where we have noticed children are exposed to 17 concurrent hazards at the same location. That's just 17 too many hazards for them. And for us to be able to know where these hazards are happening, where children live, and how vulnerable they are, I will come back to vulnerability in a second, becomes so much more important. So it's not enough just to know where one hazard could happen or happened before, because we need to adjust for the changing climate. And that's why this big data geospatial analysis becomes very crucial in how we make decisions now. Not only climate hazards, children are exposed to a variety of environmental hazards. This is an example of air pollution from 1 year, but the last estimate that we made shows us 2.3 billion children are exposed to air pollution in the world that goes above the set guidelines WHO has. And if you ask a question, how many children are there in the world? It's 2.3 billion. So practically every child on this planet is exposed to one form of air pollution that is above the guidelines of WHO, which is startling. And if there is a child under 5 who is exposed to high levels of air pollution, their brain development will be affected. So as an adult, they will have multiple different challenges for what they get exposed to in terms of environmental parameters. So far in our database, we were able to collect and gather all the climate and climate-sensitive hazards. And in the next year, we are going to look more into environmental hazards potentially if there will be data, which is another significant challenge. So it's not just air; it's water pollution, land, lead, and numerous other environmental factors that impact a child's livelihood. So once we start understanding each one of these different indicators, is how we refer to them, now we need to make sense of it, right? So that's where complex modeling comes into place. So if I go to a government official with only the maps or the geospatial data, they won't be able to do much decisions with it. It is still impactful to look at, but we need to translate in a way people can start making decisions. That's where we go from data to information to decisions. And we start crunching all of these numbers. So we understand it's not really important to know how many children are living, because countries like India, China, Nigeria, where child population is really higher, would always rank the highest. So to be able to rank all the countries in the world, then we start looking at the percentage of children who are exposed, and try to model them and bring them all together into a normalized score that people can start using to be able to understand, okay, this is the risk index in this country versus the others, and start making resource allocations or decisions that would help in a regional level on what people would be able to do. And children are exposed to a variety of vulnerability. So when I say vulnerability, it's beyond the hazards. It's already pre-existing vulnerability. Today, we all live in Italy, so we take many of these things for granted, right? We open the tap, there is fresh, pure, nice water. I mean, in Rome, there are even in streets, you can get really nice water. But that's not the case around the world. Not all children have access to water, sanitation, hygiene, good health infrastructure, good nutrition, good education, and poverty itself is a big vulnerability for many of the children around the world. And there is also child labor, child marriage. There are several other protection issues that also place into account on how vulnerable they become. So UNICEF, for the past, I believe, 30, 40 years, even before I was born, started collecting this data globally for every country to understand what child vulnerability looks like. The good news is this year is the best year it has ever been since records have started for many of these parameters. I wish this is the headline news when we open BBC, and unfortunately, media is not as excited about it. Last year has the least under 5 mortality rate, which is a huge success for the world on what we were able to do. And it all goes back in collecting data to be able to measure. Under 5 mortality is how many babies die before they reach an age of 5 years old. And believe me, there are still hundreds and thousands of children who unfortunately die. But that has reduced over time so much. So over the course of the last few decades, we have seen the child vulnerability is in a constant state of improvement. So the risks are declining. So now what we do is, now we know the hazard, we know where children are living, and we know how vulnerable they are in each one of these countries. So we start putting them all together in a map called Children Climate Risk Index that brings in all of these variables together. And as you can see, the darker areas here are where the risks are really high, because some of these countries are still developing and still reducing their vulnerability. And main impact that you see is not only the hazards, but also the vulnerability that plays into the ranking of this. So once we understand the risk, we are able to do a lot of things, right? Now we know where programmatically we should intervene. As UNICEF or with the host government, we'll be able to design programs in the field that helps people understand, okay, healthcare is what is more important, nutrition is what they need, or climate resilient wash services. So even if there is a flood or a drought, children should still have access to water, sanitation, and hygiene. So there are multiple hundreds and thousands of these projects that happens everywhere in the world, but all of those are coming from evidence that data provides us on where these programs should happen. I know I'm probably pushing it on the time, but let me quickly tell you a couple of things. So once we understand the risk, the next thing is inevitably something would happen, right? So in the world, there will not be a case where a hazard is not happening, but we have the ability to stop it from becoming a disaster. So if an earthquake happens where nobody lives, I don't think we are worried about it, right? Only when we have people impacted by it, it becomes a disaster. So alerts, early warning alerts play a very, very important role. And 15 years ago, when I just started working in this field, there weren't many alerts we got that is as sophisticated as we can today. Today, we are able to monitor every major river on this planet, and we know if the river level is going up, even in the upstream. We can alert the people in the downstream that a river flood might happen. 7-10 days before a cyclone forms, we can alert and we can precisely monitor with satellite data where the cyclone is moving and who are on its way. And many countries have started using early warning alerts to be able to save lives, literally, pre-position supplies and get people out of the harm's way, which is geospatial technology plays the most crucial role when it comes to disaster alerts and impact estimation. And the same, once something happens, this is an example from the Syrian Turkey earthquake that happened a few years ago. And this is why the data becomes so important, and data preparedness becomes so important. In the first one, you're noticing we can immediately see where the shake area was, where the earthquake happened. And since we have already developed this database, we already know which are the airports, ports, roads, railways, everything nearby to be able to get supply. With World Food Program, the first thing they do is bring food and water, because that's the most important thing right after a disaster. Before, even 3-4 years ago, we had to wait like a week or 2 weeks before we got the first satellite data. And most of us were relying on optical satellite data. And as you know, cloud cover is going to be a huge problem with optical data. So in the last few years, we have invested a lot of resources in building SAR radar technology, which can see through clouds, as you might know. And very, very quickly, now within 1 or 2 days, we are able to analyze an entire area, even if it is 10,000 square kilometer, we'll be able to quickly come and say which are the hotspot areas, because that is the first question people would have. Where should I first go? I have 100 different counties or districts affected in this country. Where should I start from? And this is already giving us this hotspot areas. And the second interesting thing that we have started doing is to use Facebook or social media movement data. And this is incredible. Even before we wait for information, Facebook with its location is able to see as a percentage. So we still won't be able to see the single person, but we can see, 20% of population moved north or south or wherever they are going. And even if all people are not using Facebook, that already gives us enough information to be able to say, let's put the soup kitchen in the north of the city rather than the south. It seems people are moving there. So many of these technological solutions play a critical role when people are trying to make decisions under pressure. Like with or without data, people have to make a decision. But this is starting to build that picture for us. And of course, the most reliable is the ground information. So when we get the geospatial coordinates on the building damages, that helps us to estimate how many people we would have to get the food for. I know there is a lot to unpack here, but I'm going to quickly summarize this. So throughout the disaster cycle, geospatial data, information, and technology plays a critical role. So we start preparing from baseline data all the way to risk analysis, understanding the exposure, vulnerability, and the hazards that could happen everywhere in the world. We map all the 196 member states of the UN. And then the couple of weeks before, this is where World Food Program is excellent. They have an automated system called ADAM, Advanced Disaster Analysis and Mapping, that gives alerts to the government, to the people, on if a cyclone is coming, if a flood is coming. And immediately after, as soon as possible, and 72-hour, the 3-day period is the most critical period, we start putting together how many people could potentially be impacted. This is all based on satellite-based analysis. And it's not only to find the people, but also to raise the resources needed, right? If we go to a donor government or any donors, we have to kind of give them, X number of people I think are impacted, and here is the evidence, the satellite-based evidence, because that's not something anybody can tap with per se. So it becomes a very solid, reliable evidence, even if it is not 100% accurate. And then we continue to support for a few months or few years in terms of conflict to help logistics get there in any way possible. There has been one main challenge in the use of this. People in general do not understand complex information. even if we do the best dashboard, it's still not going to be enough because people are very stretched, and maps is not how everybody thinks. I know I want to think maps is the center of the world, geospatial is the center, but people's mind not always work the same. So it has become very difficult over time to only use the dashboards or the maps, and sometimes there is also a restriction with the internet where we are, and we had to get creative, and that's where my interest with GeoAI came in. As Maria mentioned, I've been working a little bit with her, but also internally in UNICEF, we have been building this platform where we want to enable somebody to come in and just ask questions in natural language instead of trying to read a dashboard or a map with all the legends and all the complicated things that goes in. We tried with multiple UX specialists to see how can we simplify this, but none of that worked. And the biggest challenge was not the lack of data or lack of information. It's this gap in linking that information to people who were making decisions. Because the data and information were produced by people like us. We understand geospatial tech and we see it, we have been used to it. But on the other hand, people are not used to it. So I will send a map, some might use it, some might not. And now we're quite excited. It's still a long process. So we want to be able to give this platform and say, if I am an emergency manager in northern Nigeria, and I can come in and ask a simple question, how many children are exposed to floods in northern Nigeria? And it's able to now retrieve the data from our own database that we have been collecting for years now, and split the information very quickly, approximately. I would like to do a very quick demo, but Maria, let me know if you want me to pause, or shall I do a quick demo?
No, I believe that you can start immediately the demo. The only point is the website open in such a way that if the students want to try by themselves, they can do that, or it's still closed and in production?
It's still hosted at our end because we are still in the testing phase, but eventually our aim is to make it publicly available, but unfortunately I think not just yet. I hope it works. So I can come in and ask a question like, how many children are exposed to, let's say, tropical storms in Fiji? And we want it to be as transparent as possible. So you can see with the LLM, we also incorporated with the agent thinking and try to identify, okay, these are the data sources that I am using. I'm going to retrieve the boundaries because we have to use official data for all of it. And it retrieves the data and does a very quick analysis to like a spatial summary of it, and visualize it and reports back on how many children are. So it gets me the map, and it shows me not only where the hazard could happen, but most importantly, where children are exposed to that particular hazard. And then gives me approximately 200,000 children in Fiji, which is almost all the children. It's an island country where typhoons happen quite often, and gives a little bit of information about what it thinks. So the idea now is to build this further and try to have a GeoAI solution that can be scaled up, not only to know how many children are exposed, but also what do I do with this information? Okay, now that I know, what are the programming activities I could think about? What are the climate resilient education or wash or nutrition, each one of the sector activities I could do? So that's what we are working now, to not only have the geospatial LLM, GeoLLMs, but use the text, but with multiple documents, we have hundreds of it, to train the model to have both the information for the user. But users could even ask questions like, what is a heat wave? Because it's not something that has a global definition and people might not know. And it should be able to get, okay, this is what the heat wave, this is how I define each one of the dimensions of heat wave, these are the threshold I'm using, and gives a little bit of information, easy, very quick information. But it's not without its challenges. It still hallucinates, which we are trying to figure out why, and it's very complicated with the large language models. But I'm more than convinced that this is the future. I'm guilty of making a lot of used less dashboards. I'm not saying useless, it's used less. And static maps and dashboards still have their room and value, but I think we are shifting completely in the geospatial sector. And in the next couple of years, GeoLLMs would be at the center of it, and we would be able to access many data very easily. Anyway, Maria, maybe I could pause